Here we are given a complex fraction, and we are asked to simplify it. Complex fraction is a fraction that has fractions within it. I'm going to refer to these smaller fractions separately from the overall large fraction as we're working through the problem. The first thing you'd want to do in order to simplify this complex fraction is make sure that the denominators of all the smaller fractions are factored. And in this case we can factor x squared minus 4. So let's go ahead and do that. We have 6x over x minus 2, x plus 2. And then in the second one I have 7 over x minus 2 because it does not factor. Similarly with the fractions in the bottom, no factoring is necessary. Notice that I've left some space between my fractions because in my next step, what I want to do is I want to try to eliminate the denominators of these smaller fractions. And the easiest way to eliminate these denominators is to multiply all 4 of the smaller fractions by their least common denominator. So what would the least common denominator be for these 4 fractions? Well, it would be x minus 2 times x plus 2. And so what you're going to do is multiply all the numerators by x minus 2, x plus 2. If you like, you can write over 1 just to make sure it's clear that it's the numerators of each of these smaller fractions that is getting multiplied by x minus 2, x plus 2. The reason you're allowed to do this is because you are doing the same thing to the top and bottom of the overall large fraction. And so that keeps it balanced and doesn't change its value. Once you've written in next to each of the smaller fractions x minus 2, x plus 2, then what's going to happen is you're going to be able to cancel, and in the next step things are going to look a lot cleaner. So let's look at this first term that we had here. What can we cancel? Well, luckily for us, there's an x minus 2 in the numerator and the denominator now, and also an x plus 2. So all of those will cancel, and all that would be left in that particular expression is 6x over 1, which we don't need to write if that's all that's left. Now if we go on to the second term, we have some more that can cancel. The x minus 2's can cancel. So we'll be left with a minus 7 and an x plus 2. Just be careful that you remember that minus sign goes with the 7. And it will be multiplied onto the x plus 2. In the bottom half, let's see what can cancel. We have in this term here x minus 2's canceling, leaving us with just 5x plus 2. And finally, in the last part, right over here, we can cancel the x plus 2's. And so we would just have plus 6 times x minus 2. Okay, from this point we're going to need to do some simplifying at the expression and see what you can do in order to clean it up. We're going to want to distribute the minus 7 in the numerator, so that would be minus 7x minus 14. And then in the denominator we're going to distribute the 5 and the 6. So 5x plus 10 plus 6x minus 12. We can combine some like terms. In the numerator, 6x minus 7x is negative x minus 14. And then in the denominator, we have 11x minus 2. At this stage, once you've cleaned up the complex fraction and you have a simple polynomial in the numerator and the denominator, you do want to check if it can be factored, because if you can factor either part, then you would want to factor them in order to check for possible canceling. In this case, though, neither of the expressions factors, and so the rule is if it doesn't factor, it doesn't cancel, and so that just means stop. You have completed the problem.
Made with Doodlecast Pro.